when astronomers first calculated the trajectory of 3I Atlas. Their results led to an unexpected conclusion. This object wasn't merely passing through the solar system. It had arrived from interstellar space, having crossed, according to preliminary estimates, several dozen light years. This is a real fact, confirmed by measurements of its extremely high velocity and hyperbolic orbit. Yet these very parameters raised more questions than answers. According to official models, interstellar objects should move chaotically, without any sort of corridor. But some scientists noted that the path of 3I Atlas seemed to run along the most energetically efficient zones of interstellar space. Some believe this may be a simple coincidence. But there is also a hypothesis. The trajectory resembles a route used by automated probes that take advantage of gravitational optimization. After a detailed analysis, it turned out that at various points in its journey through the galaxy, 3I Atlas may have passed near several stars, including an M-class red dwarf that was significantly closer to our region about 1.3 million years ago. This is an astronomical fact. But according to certain indirect indicators, that point in time may have been when the object received additional acceleration. How exactly, no one explains. Online speculation suggests that 3I Atlas may not have been simply drifting, but instead was ejected from another star system as a result of a gravitational resonance with an unknown massive object. Other researchers argue that the idea of artificial origin cannot be completely dismissed. Their reasoning is simple. The trajectory is too clean, without signs of numerous collisions typical for most debris-like cosmic fragments. An interesting detail was noticed by specialists analyzing spectral data. They claim to have occasionally detected weak but regular deviations in reflected light, which could hint at a surface structure unlike natural rocky bodies. No official source comments on this, and some experimental data disappeared from catalogs just days after publication. Whether this was a regular update remains unknown. Some observatory staff members anonymously confirmed that certain archival files containing early observations of the object were marked with the internal status, restricted access, a label typically not used for natural comets or asteroids. Why such a measure was necessary, no explanation was given. According to one researcher working with interstellar media models, the motion of 3I Atlas appears as though it deliberately avoided dense gas dust clouds. This could be coincidence, but it could also indicate that the object maintained its course far more precisely than expected from a simple fragment. The hypothesis sounds bold, but it does not contradict physics. Even a very weak reactive impulse could alter a path across light-year distances. Some suggest that this is precisely why 3I Atlas arrived in the solar system not by chance, but as if pre-directed toward us. Whether this is true is for each to decide. The fact remains that its journey through the galaxy contains more blank spots than explanations. There are many versions, and none of them have been disproven. Analyzing the possible path of 3I Atlas through the Milky Way, astronomers were able to determine only the general direction of its motion. The real fact is that the object arrived from a region of the galaxy dominated by a high concentration of old thick-disk stars. This immediately changed the tone of the discussion. Objects originating from such regions usually have a composition different from that of the young comets in our system. But the spectrum of 3I Atlas revealed far more CO2 than expected, the first fully legitimate strange signal. This coincided with the fact that the object's trajectory had an almost perfectly hyperbolic eccentricity, 1.2. Some researchers believe that such an orbit not only confirms its interstellar nature, but also suggests that 3I Atlas traveled steadily, without signs of numerous collisions or fragmentations typical of long-lived comets. In other words, It seemed to have passed through the galaxy unscathed, which is a bit suspicious for an object that may have wandered for billions of years. Speculation online suggests that 3I Atlas may have moved along so-called galactic corridors, regions where the density of gas and dust is minimal. If true, such a path could greatly reduce the likelihood of destruction. The official stance is more conservative. It's merely coincidence. But those who analyzed maps of the interstellar medium claim that the object indeed traveled as though avoiding hazardous areas, as if someone or something had pre-selected the route. According to certain indirect data, scientists had already detected large interstellar bodies from the same direction several years ago, but that information never appeared in open catalogs. Why unknown? Some even think 3I Atlas may not be the first, only the first noticed. Officially, however, no such claim has been confirmed. There is another intriguing detail. At certain points along its long journey, the object may have passed near zones of intense radio emission, regions typically associated with galactic storms. Yet, according to the reconstructed orbit, it never entered any area that could have seriously damaged it. Some experts don't rule out simple luck. Others cautiously hint at the possibility that the object had unusual resistance to cosmic radiation. Several employees of a European observatory who worked with early models anonymously claimed that the first computer simulations of the 3I Atlas route showed not one, but two possible trajectories, one of which was absolutely perfect, without any deviations. After recalculations, that trajectory disappeared from the model, and the files themselves were overwritten. No official explanation has been given. Certain enthusiasts noticed that during the period when 3I Atlas was traveling through interstellar regions, several satellite images contained dark patches in zones where reflected light from microparticles was expected. These patches appeared and vanished within a few hours, and their origin was dismissed as incorrect frame processing. Whether this is true remains unknown. There is a growing idea that the journey of 3I Atlas through the galaxy was not simply the drift of a fragment, but something more deliberate or controlled. Though there is no hard evidence, at least not yet. Perhaps this is modern myth-making. Or perhaps we truly witnessed something that exceeds the boundaries of familiar models. Everything may turn out to be simpler or far more complex. Scientific circles are well aware that interstellar space is far from empty. It is a complex mixture of gas, dust, magnetic fields, and plasma flows. Any object traveling through such environments for billions of years should accumulate at least some damage, erosion marks, microfractures, loss of volatile elements. Here is where 3I Atlas presents a curious anomaly. According to spectroscopic studies, it appears far fresher than a fragment that has traveled hundreds of trillions of kilometers should. This is a verified fact, confirmed by independent research teams analyzing data from multiple telescopes. The interpretation of this phenomenon is debated. Some argue that the object's unusually high CO2 ice content explains its youthful appearance, since CO2 sublimates more slowly than other volatiles. However, other astrophysicists note that even so, the surface should have lost some material. Yet the outer layer of 3I Atlas appears almost untouched, as if sealed. Online speculation suggests that the object might have had some form of natural protection. For example, a hard shell formed by freezing or extreme temperature conditions. But some researchers caution that one cannot entirely dismiss the possibility of artificial reinforcement of the shell. Not as proof, but as a hypothesis. The surface might have been strengthened by heating, compression, or an unknown process that made it unusually resistant to interstellar effects. Intriguingly, on a particular day when polarization measurements of 3I Atlas were conducted, instruments in the US and Europe reported differing results. Some data indicated a homogeneous surface, while others suggested anisotropic zones, potentially pointing to a heterogeneous material structure. According to indirect sources, parts of these observations were later marked as technical errors. Yet several specialists quietly note that this many errors appeared within a single short observation window, which is unusual. Some staff at the Hawaii Observatory anonymously reported observing a strange effect. At certain moments, light reflection from 3I Atlas nucleus exhibited sudden phase changes, as if the object were turning or altering its reflection plane. This could indicate an uneven surface or some underlying structure beneath the ices. The files containing these measurements were removed from public access for verification, but have not been restored. Satellite reconstructions of the trajectory revealed another detail. The object seemingly accelerated slightly after passing through a region of interstellar space with weak, stable magnetic fields. The official explanation is a calculation artifact. However, some speculate that the object reacted to its environment differently from natural debris. Certain analysts even suggest it moved as if it had an internal stabilization mechanism, a notion bordering on the fantastic. The core question remains: why did 3I Atlas remain so well preserved after its colossal journey across the galaxy? Is this a unique property of its material, previously unknown to science? Or was its path through the galaxy not as chaotic and dangerous as commonly assumed? There are many versions, and none has received definitive confirmation. While analyzing possible stops and intersections along the interstellar path of 3I Atlas, some researchers focused on an easily overlooked detail. The object passed through regions not only relatively safe in terms of gas density, but also characterized by anomalously low radio background. This is a real traceable fact, based on interstellar maps from NASA and ESA. Yet the interpretation adds an intriguing twist. Such regions are sometimes called radio shadows, zones where cosmic radiation is suppressed by natural structures of the interstellar medium. Speculation online suggests that 3I Atlas might have used these radio shadows as natural corridors that reduce exposure to harmful radiation. At first glance, this sounds logical, but it raises a question. How could a natural fragment wandering chaotically through the galaxy so precisely navigate into these zones? Some scientists chalk it up to coincidence and vast timescales. Others propose another idea. The trajectory of 3I Atlas may not have been entirely chaotic, perhaps partially guided or at least stabilized by unknown processes. Astronomers working with gravitational interaction models reported that several points along its route exhibited what they call anomalous momentum retention, moments when its velocity did not decrease as expected. The official explanation: data inaccuracies. But a few specialists noted that these moments coincided with the object passing near boundaries of interstellar clouds, where magnetic fields often shift. Could such interactions give the object additional stabilization? Theoretically, yes. Could they resemble artificial course correction? That remains debatable. Around the same period, several satellites detected changes in the electromagnetic background in regions crossed by the object. Access to some of this data was cut off almost immediately after publication, attributed to technical updates. Whether this was coincidence is unknown, but screenshots captured before the block showed sharp spectral jumps unusual for those parts of the galaxy. Some online commentators suggested these changes could have been a reaction of the object to its environment, though no official source has addressed the idea at all. Staff from several private astronomical centers anonymously claimed that certain archived trajectory maps containing information about the early stages of 3I Atlas's motion were replaced with new versions, in which key route points had simply disappeared. No explanation was given. Some think this was routine data revision. Others suspect that the old files contained indirect hints that officials preferred not to leave publicly accessible. Another detail draws attention. According to modeling, 3I Atlas passed near several stellar systems with elevated probability of hosting Earth-like planets. Some papers even suggested that one of those systems might have had material similar in composition to what is seen in 3I Atlas. Could this be coincidence? Certainly. But some hypothesize that the object could be a fragment of a long-lost planet or a remnant of a system destroyed by a catastrophic event. Altogether, this paints the impression that 3I Atlas did not simply fall out of cosmic chaos, but arrived here through a chain of events that fits together a bit too neatly. Whether one should see intention behind it, that is for you to decide. Sometimes the greatest mysteries lie not in the facts themselves, but in the spaces between them. One of the most mysterious details in the entire history of 3I Atlas was the strange behavior of the object's light curve. That is, how its brightness changed over time. At first glance, this characteristic may seem purely technical, but it was the light curve that made many astronomers suspect. 3I Atlas might have something unusual that cannot be explained by standard models of comets or asteroids. Official reports state that the dimming of brightness occurred unevenly. During some periods, short flares were recorded, which went against the expected behavior for an object moving away from the sun. Such flares should indicate activity, for example, the release of gas or dust. But their spectral analysis showed something completely different. These peaks lacked the chemical signatures typical of cometary emissions. This means that the brightness changed, but not due to the sublimation of frozen substances. The question arises, why then did 3I Atlas blink? One hypothesis is uneven reflection of light from an object with an unusual shape. However, this is where the most controversial part begins. Models attempting to reproduce its light curve could not find a shape that would explain the anomalies without introducing additional assumptions. Usually, such models are fitted in a few hours. But for 3I Atlas, they either did not converge or required such extreme parameters, like an extremely elongated or hollow structure, that scientists began to question the method itself. In some circles, the version circulates that the object might have had a so-called fractal surface, uneven and multilayered, responding to sunlight in an unusual way. Such surfaces sometimes appear as a result of the destruction of fragile materials or after passing through powerful explosive events. This could explain why the light reflected so unpredictably. But it also raises questions about the past of 3I Atlas. What processes could have created such an unusual structure? Another unexpected aspect is the absence of a stable rotation period. In most similar bodies, it is possible to determine the exact rhythm with which they present a specific face to us. But in the case of 3I Atlas, this period constantly floated, as if the object adjusted its motion in response to some external or internal forces. Officially, this was explained as chaotic rotation. But several independent groups noted that the chaos here was too structured. It repeated in certain patterns that are difficult to attribute to randomness. These anomalies drew the attention of light dynamics experts, specialists studying the interaction of radiation with matter. One of them, analyzing the data, compared the behavior of 3I Atlas with so-called passive adaptive surfaces, technologies that change light reflection depending on the angle of incoming rays. In space technologies, such materials are used to stabilize spacecraft without using fuel. Does this mean that 3I Atlas is artificial? No. But it does mean that the object's light curve has properties that do not fit within the classic framework of a natural fragment. Standard explanations exist, but they all require additional conditions. making the picture even more mysterious. The study of 3I Atlas became a lesson for scientists. Space can create structures that we cannot immediately classify. And if a light curve is indeed a kind of signature of the object, then 3I Atlas left a signature that no one can yet decipher. The trajectory of 3I Atlas through the galaxy, according to official calculations, appears as a random result of millions of years of drift between stars. But when scientists began overlaying it on a map of known stellar streams, several features emerged that not everyone is willing to call mere coincidences. The first real fact: the object moved at an extremely high speed, approximately 60 kilometers s relative to the Sun. For interstellar fragments, this is possible but not very typical. Interpretation: such a speed means that 3I Atlas was either ejected from another star system or passed by something that gave it a strong gravitational impulse. And this is where the first conspiratorial assumption appears. Some researchers believe that the object may have crossed a region with an extremely dense mass, possibly even an as yet unknown type of compact body. Indirect data suggests that at early stages of analysis, NASA modeled whether 3I Atlas could have passed near a stellar mass black hole somewhere in a remote region of the galaxy. The results of these simulations were never published, although similar studies usually pose no secrecy. Journalists who tried to find out details reported that access to part of the files was restricted during the first day. Why, no one explained. However, there is another interesting fact. The trajectory of 3I Atlas did not simply pass through random regions of space. It almost perfectly intersected a galactic arm, where over the past decades radio signals of unclear origin were repeatedly recorded. They were not classified as artificial, but neither were they attributed to ordinary cosmic noise. Online speculation suggests that 3I Atlas may have passed through the same region where several independent radio telescopes recorded brief, fast radio bursts of unusual character. Another peculiarity is related to chemical model analysis. There is a view that the material of 3I Atlas was exposed to extremely intense radiation. This is evident in the spectrum. Certain molecular bonds are broken as if the object had been in a zone of high-energy events. Such traces remain, for example, when a body passes near neutron stars or encounters supernova shock waves. But the problem is that, according to known models, it should have disintegrated or been completely destroyed. Yet 3I Atlas remained intact. Some experts suggest that its structure could have been extremely dense enough to withstand galactic cataclysms that would destroy any ordinary comet. There is an idea that such dense bodies could be parts of planetary cores, stellar fragments, or even exotic astrophysical objects that we do not yet know how to classify. But there is also a more nebulous version, the one that provokes the most controversy. It talks about a possible guided drift. Not in the sense of a spacecraft flight, but in the sense that 3I Atlas could have followed a certain route formed not by random gravitational events, but by a consistent sequence. This idea is based on the fact that the object's trajectory several times strangely repeated the direction of a series of distant points, which in various cultures were described in ancient myths as gates to other worlds. No official source comments on this, but no one denies it either. Was it an ordinary fragment that drifted between stars for millions of years, or part of something larger? The question remains open. There are many versions, and none of them have been refuted so far. When projecting the path of 3I Atlas in reverse, astronomers attempted to determine its point of origin. This is standard practice for interstellar objects. If the trajectory is traced far enough back, one can estimate from which stellar system the fragment was ejected. However, in this case everything turned out to be far more complicated. The real fact When attempting to trace the object's path backward, the models began to diverge after only a few thousand years. In other words, the trajectory did not converge to any specific system. Interpretation: either 3I Atlas passed through a region with strong gravitational perturbations that distorted its previous motion, or the object itself has properties that complicate classical calculations. This became the foundation for one of the most intriguing conspiratorial hypotheses. Some believe that 3I Atlas may have passed through a region of space where an unknown form of gravity operates, something like a compact gravitational knot. Such structures are not officially confirmed, but several scientific papers have speculated about their possible existence. According to certain indirect data, NASA and ESA conducted calculations to determine whether the object might have flown near a miniature black hole or a remnant of a massive star that cannot be directly observed. For some reason, the results of the analysis were never released. When journalists attempted to locate the documents, several files in the database had been removed. The official explanation: access error. But online speculation suggests that some results might have challenged standard models of galactic dynamics. But there is an even stranger coincidence. Astronomers working with unique catalogs of stellar motion in the Milky Way noticed that one of the directions indicated by the reverse trajectory of 3I Atlas points toward a restricted region known as the Perseus, Pegasus Void, a vast area of space with an anomalously low concentration of matter. Officially, this proves nothing, but some researchers believe such voids may be remnants of ancient cosmic processes we barely understand. Around the same time, enthusiasts analyzing the same catalogs noticed another curious detail. Several stars in that direction exhibit unusually strong shifts in their spectral lines, as if colossal events had occurred in their systems. Whether this could be related to 3I Atlas is difficult to say, but the parallel is certainly intriguing. Several employees of one observatory anonymously claimed that during early attempts to reconstruct the object's path, the trajectory somehow disappeared from the model at a certain distance, as if the data stopped matching. This was attributed to computational errors, but a few days later the updated calculations no longer contained any of those odd discrepancies. Why the early files were not preserved has not been officially explained. In addition to this, several older satellite surveys showed a dark area, a sort of image defect, precisely in the spot toward which one of the reverse trajectory variants pointed. A few hours later, these images were replaced with corrected versions. Only those who managed to download copies before the replacement reported it. Skeptics say that all these coincidences are simply the result of overly flexible interpretations of data. But others emphasize, when the same anomaly reappears over and over, it no longer looks like coincidence. Are they hiding something about the true origin of 3I Atlas? Or are scientific models simply not yet precise enough to reproduce its path? Everything may turn out to be simpler or far more complex. As 3I Atlas had already left the solar system and was moving farther into interstellar space, researchers attempted to understand not only where it came from, but also where it was headed. The real fact: analysis shows that its new trajectory leads toward the galactic outskirts, a region where the density of stars decreases and cosmic space becomes increasingly empty. In scientific terms, this is a standard result for an object that was merely a random visitor. Interpretation: 3I Atlas is simply continuing its journey without interacting with anything significant. But at this point, another series of assumptions emerges, giving the story a different, less official undertone. Some believe that the object's direction of travel is not as random as it appears. Several independent groups of astronomers overlaid the trajectory of 3I Atlas onto maps of microwave emissions and distributions of cold gas in the galaxy. And they noticed something strange. The object's path runs almost parallel to a little-known stream of interstellar gas that moves with mysterious acceleration. It was discovered back in the 2010s, but no explanation has ever been found. There is a growing idea online that 3I Atlas might be a fragment of some long-destroyed body that once moved along with this stream. Whether the stream is natural or has a different origin remains an open question. No official source has even hinted at the possibility of an artificial nature, yet some enthusiasts are convinced. Coincidences like this are too rare. Furthermore, in the very direction where 3I Atlas is headed, several weak radio pulses were detected, repeating at identical time intervals. At first, these were attributed to a pulsar, but analysis showed the periodicity was unstable, as if something were trying to imitate a natural source, but not quite successfully. Why these data quickly disappeared from public archives is not officially explained. Some researchers believe these impulses could have been entirely random events, but others point to an interesting detail. Part of the signals occurred exactly during the period when 3I Atlas passed through a region of increased magnetic turbulence. According to certain indirect reports, one of the radio telescopes recorded a short spike, one that looked as if the object reflected the signal. The file containing this fragment vanished from the database a few hours later. There is even a theory that the object could have been part of some larger structure, possibly a fragment of an astrophysical mechanism, a stellar remnant, or even something complex that was destroyed long ago. Not necessarily artificial, but not easily understood either. Several observatory employees anonymously stated that they saw something strange in the telemetry as the object left the inner regions of the solar system. They did not reveal details, fearing the loss of their jobs. What exactly they meant, nobody knows, and their silence only fuels speculation. There is another mystery related to optical observations. In two different sets of images, a dark spot appeared not on 3I Atlas itself, but nearby, a few thousand kilometers away. It was visible only in a specific spectrum, and on subsequent images it vanished. The official explanation: an image processing artifact. But some experts believe it might have been a reflection or a secondary object traveling alongside it. Was it a companion fragment? A shadow of an unknown gas structure? Or perhaps something they do not want to tell us about? For now, no answer exists. 3I Atlas continues its journey into the darkness of interstellar space. And only one question remains. Was it a random wanderer, or part of a story we are only just beginning to notice?